Now let's take a look at a circuit that's in parallel. And when we have objects that are in parallel, the same process will be applied, except that because we have more than one loop, what that means is that our values, or the application of the values, that being the current and potential difference, changes. And what Kirchhoff's law tells us about things that are in parallel with each other is that they don't have the same current. So I have a number of electrons that come up to a point, they have a branch, they can go down one of two paths. Some will go down one path and some will go down the other. And so therefore the sum of the potential differences down each of the paths is equal to the current that comes up to that branch. And then they rejoin back up afterwards, wherever the branches rejoin. But because the electrons don't go through each of the loads, what that means is that my loads will have the same potential difference. So again, let's take a look at an example. And in this example, we have two resistors that are in parallel to each other. One is a 15 ohm resistor, one is a 30 ohm resistor. Okay, and they're connected to a 60 volt power source, and we want to determine the values for each of them. Now, just like we did for our first example, our first thing to do is to label each of our entities in our circuit so that we can keep track of all of our values, and we know what values go with which object. And so now we can see that we know that our potential difference at our power source is 60 volts, and we know the resistance of our two resistors. Now, because this is a parallel circuit, what that tells me is that my electrons are going to come out of my power source, they're going to come down the wire, they're going to come down this wire, and then they're going to come to this junction where they can go down this path or they can go down this path. So therefore, the sum of the current for this path and this path is equal to the current that came out of this or that came out of my power source. Because the electrons only go through one load, and they come out, they go through this load and back, and we know that the potential difference applied has to be consumed by the loads in the circuit. What that tells me is that the potential difference of the loads will be the same, and will be the same as the power source in this case because I have no other resistors. Okay, and through a manipulation of this equation using Ohm's law, we get that our total resistance in this case is 1 over R1 plus 1 over R2. So now we can start using this and we can start solving. So the first thing is 1 over R, my total resistance is equal to 1 over the resistance of my first resistor plus 1 over the resistance of my second resistor. So 1 over 30 plus 1 over 15. Now because these are fractions and we want to add them together, we have to use proper math principles, and we need a common denominator. And so in this case, the common denominator of these two values is 30. So therefore, I'll just change this fraction to a fraction of over 30, and I had to multiply the denominator by 2, so I multiplied the numerator by 2. So now I have 1 over 30 plus 2 over 30, that's 3 over 30. Now when I flip this equation, now that it's a single fraction rather than sum of fractions, I get that my total resistance is equal to 30 over 3, which is 10 ohms. So what that means is when I have a 15 ohm resistor connected to a 30 ohm resistor in parallel, the overall resistance actually decreases, and it's less than the resistance of each of the resistors. Whereas when they're in series, since the resistance added together, the overall resistance of the circuit is greater than the individual resistors. Okay, so now that I know my overall resistance, this will allow me to get my overall current. So now I know that 60 volts is applied at the power source. My circuit has 10 ohm resistance and it has 6 amps. Now that we know those values, we can move on to each of our individual resistors. And because they are in parallel with each other and through Kirchhoff's law, since a potential difference of 60 volts is applied to the circuit, we know that each of these resistors has a potential difference of 60 volts. So from that, I now know the resistance and the potential difference. So I can use Ohm's law, where V equals IR, so I is equal to V divided by R, to get the current for each of my two resistors. And likewise, what we did before, we can see that 6 amps comes out, a current of 6 amps comes out of my power source, 4 amps goes down one of the branches, 2 amps goes down the other, and that totals 6 amps in total.